Welcome back. In the previous lecture, we estimated an initial PD model, selected features based on statistical significance, and estimated a final PD model with the selected features only. Now let's see how we can interpret the coefficients of this model. Earlier in this section, we looked at what the coefficient of a dummy variable in a logistic regression model means. We saw that the exponential of a coefficient of a dummy variable shows the change in the odds for an event occurring between an observation with a 0 value for that dummy variable and an observation with a value of 1. According to our definition of the good-bad variable, the event occurring is non-default, that is, being a good borrower. So, higher coefficients of dummy variables in our PD model mean greater odds of being a good borrower and, correspondingly, lower odds for default. Let me explain what serves as a comparison. Well, we compare them to the reference categories we left out of the model precisely for that purpose, to serve as a reference point. How so? Well, if an observation belongs to the reference category, it will have values of 0 for all other dummy variables that represent an original independent variable. So the odds of being good for that observation, compared to an observation that belonged to another category, will be an exponent to the power 0. While if an observation belongs to another category, its odds will be an exponent to the power of the coefficient of the respective dummy variable greater than the odds of the first observation. To clarify, we can use an example from the model. Let's take the first original independent variable, the grade variable. As you know, there were 7 initial categories of external grade, represented by the letters from A to G. So in terms of weight of evidence with respect to the good-bad variable, A is the best one, G is the worst. That's why we decided to make G the reference category. In fact, we got all positive coefficients for the dummy variables we included in the model, from A to F. That means observations with these values are all better than observations with a rating of G. Furthermore, we can see here that going from F to A, the coefficients are increasing in magnitude. In other words, the odds of being good are increasing as the external rating is increasing. And that's just how it's supposed to be. But what exactly are the odds for someone with an external rating of, let's say, D, to be better than someone with an external rating G? The ratio of the odds for someone with an external rating D to be good are an exponent raised to the power of the coefficient of the dummy variable, that is, an exponent raised to 0.5012. That's approximately 1.65. So the odds for someone with a rating of D to be a good borrower are about 1.65 times greater than the odds for someone with a rating of G. Similarly, the odds of someone with a rating of B to be a good borrower are about 2.42 times greater than the odds for someone with a rating of G. As you may have noticed, we pretend that the reference category has a regression coefficient of 0 here. The reference category serves to compare the odds of the rest for the dummy variables to it. Thus, it can also help to compare them with each other. We know that the odds of someone with B to be good are 2.42 times the odds of someone with G to be good. We are also aware that the odds of someone with D to be good are 1.65 times the odds of someone with G to be good. Therefore, the odds of someone with B to be good are 2.42 divided by 1.65 times greater than the odds of someone with D to be good, or about 1.4671. At the same time, we don't really need another point of comparison for the two categories. We know that the odds of someone with D to be good compared to someone with a rating of G are an exponent of the coefficient of the D dummy variable. Furthermore, the odds of someone with B to be good compared to someone with a rating of G are an exponent of the coefficient of the B dummy variable. So, we can easily deduce that the odds for someone with B to be good compared to someone with D are an exponent of the difference of the coefficients of the two dummy variables. That is, an exponent raised to power 0.8845 minus 0.5. That yields about 1.4671, exactly what we got before. Well, That's how we can interpret the coefficients for every set of dummy variables representing an original independent variable. Note that such direct comparisons are possible only between categories coming from one and the same original independent variable. For example, it won't be accurate to compare the odds of someone with external rating B to be a good borrower to the odds of someone with employment length between 5 and 6 years directly based on the coefficients we got. That's due to the fact that some people with external rating B actually have employment length between 5 and 6 years. In other words, the two groups won't be mutually exclusive. While, as we have ensured by definition, all dummy variables coming from the same original independent variable are mutually exclusive. Each observation belongs only to one of them and does not belong to the rest. Thanks for watching, and see you in the next lecture.